Hey guys, I'm back. You didn't know I was here, but I did a 25-minute video reviewing Friday and Monday for you, and it didn't upload. So I'm back here at it again. So I'm going to change my plans a little bit, and I'm going to tackle Monday here, and then I want to do another video for you guys with the calculator based on Friday stuff, a little bit of Friday stuff, and the Cubs and sunny day, cloudy day data on today's stuff. So we'll kind of move through this real quick. So let's kind of tackle what I already tackled once, but hey, oh well. So let's talk about it. See, it's like right there, 5-number summary. You can kind of see it. I already wrote it once. Let's write it twice. So 5-number summary. Let's talk about that. So right now, if you didn't do the notes in the book for Friday, it may be a little bit confusing because that's what the terminology we're going to use. So 5-number summary. Guess what? There's 5 numbers. First number is our minimum. Second number is our Q1. Third number is our median. Fourth number is Q3. And our fifth number is our maximum, and that does not include outliers. Don't include outliers in that. So if they're past, if there's an outlier out there, you drop down to the maximum number that doesn't include the outlier. All right, so remember, this is a 5-number summary. 2 things. You can find it in 1-bar stats in your calculator. It's much easier to deal with. And the second thing is we use these for skewed graphs. All right, I'm going to double check, make sure this video is working. Hey, it's still working. I think it was user error. So, it asks you on the next piece to draw parallel box plots for the beef and chicken sandwich data from the previous lesson. Again, if you didn't do it on the previous lesson, this may it'll help you a little bit, but it may be a little confusing. So that's the chicken one. I'll just do the numbers for chicken. I have 10, 26, no, wrong one. I have 9, 10, 16, 17. 9, 10, 16, 17. And then I have maximum, which is 28. All right. And then I have my beef data. We have our beef data. So we have our beef data, and it's 9, 19, 26, 9, 19, 26, 9, 19, 26, 39, 42. All right, so always draw our scale. So we look at the data here. The data is going to be, all right, that's going to be a 10. So I'm going to go 10, 15, 20, 25, 30, 35, and 40. Go out to 45 if we want to, just to cover this guy right here. So I'm going to go to these plots here. This is going to be grams of fat per sandwich. And then I'm going to do the chicken one here. So I'm going to go 9, draw a line to 10. So if we look at it, we're going to go in this order here from left to right. So it's going to go minimum, Q1, median, Q3, maximum. And then I'm going to draw the side of a rectangle. And then I'm going to go to 16, where my median is. Put a line, so that's my median. And I'm going to go to 17. Finish the box, and then I'm going to go from Q3 out to 28 and put my data there. And remember, this is the chicken. So if you wanted, this is minimum. This is Q1, median, Q3, max. Okay? All right, so Let's look at the beef. The beef is at 9 also, so this is the beef numbers. And then I'm going all the way to 19 to Q1. Remember, this is minimum. This is Q1. Then I'm going to go to my median of 26. I'm going to go to my Q3 of 39. So this is median. This is Q3. And I'm going to go to my max of 42. So that's what they look like. So this is the box plot. These are box plots. They're based on the 5-number summary, and they're always done for skewed graphs. So if we kind of look at these things from Friday, we calculated what was called the IQR. The IQR is from here to here. This is the IQR. So this box represents the IQR. This box here represents the IQR. So 50% of the data is in between Q1 and Q3. So what we can say about beef is that 50% of all sandwiches contain between 19 and 39 grams of fat. Chicken, we can look at 50% of the data, 50% of the sandwiches contain between 10 and 17 grams of fat. So which one has more fat on average? Well, by far, the beef. The IQRs are separate, and if you look at it, 75% of the data is greater than 19, because remember, each one, it's a quartile, 25, 25, 25, 25. And then 75% of the data is below 17. So you can see visually that it's that way. And remember, we can use SOX. Since the data is all this way, this is going to be kind of a skewed to the left data point. This is definitely skewed to the right because it's got a data point way out here. So we can draw it. So if we were to draw that one, well, 75% of the data is on this side, and so it would be skewed to the right. Be skewed to the right. All the data is on the left. It means we pulled the X bar to the right. So we can look at different things. We have outliers. We have none. We have a center. Median's the center. Median's the center. We can compare those. And then if we have spread, our IQR is much larger, and the range of the two don't even meet. So we definitely can say that beef is much larger. So draw the parallel box plots for the Cubs and the cloudy, sunny day data I'm going to do on another video on the calculator. So let's look at what are some weaknesses for the box plots. We can't really draw peaks. I know I did here, but I mean, honestly, this thing could, on a histogram, could be like, there's a tall one here, there's a big one here, a big one here, there's nothing there, and then it's way out here like that. So we can't draw, there's nothing here. We don't know where the peaks and valleys are. So these things can do anything in between here. Like this one here, it could go up, and then it could have nothing here, and then it could go back up and down. And so we don't know what's happening in between. All we know is based on the box plot, that's looking like where the data distributed. So the weaknesses of the box plots is that you can't draw your peaks and valleys, and you don't know where they're at. We don't draw them normally, but we just don't know where they're at. So we can't really do a lot of analyzing of the data at times. So let's go ahead, and you guys can try the Hank Aaron data and try to draw one of these on your own. And you can pause the video, and I'm going to put the answer up here real quick so you guys can see it. So if you want to pause the video and see if you can draw it and answer the question. So we are going to pause the video. Don't forget, if you don't want to hear the answer, we are going to do home runs per game. And at home runs per game, we've got 10, and we'll go 20, 30, 40, 50, 60, 70, 80. All right. So then I'm going to do Hank Aaron in red. He's 10, 26, 34. 10, 26, 34, and 44, 47, I think. 44, 47. So that's Hank Aaron's data right there. So this is Hank Aaron. All right. Let's do Barry Bonds, 16. Oops. 16, 25.5, 34, 25.5, 34, 40, whoops, 45, and 73. 45, and 73. So, this is what it looks like right there. So, the question is, on average, explain who hit the higher number of home runs. So, on average, remember, average is like with X bar, we have a skewed to the left, so this one's skewed left. So that means X bar went this way. And this one is skewed right, so X bar went this way. So on average, we're going to say Barry Bonds hits more home runs on average in the season. But remember the weaknesses behind box plots. We don't know what's happening here. Is there only this one? If there's only this one, then we may be at a different point when we actually compare them. So that's on average, that's what it would look like. But then you would want to truly, you can't just compare on average. We know they're skewed. We're using a 5-number summary. So you need to really compare them, if you want to do it correctly, by SOX. Shape, outlier, center, spread. So here we go. That's the answer to that last one. And I'll do the calculator one for you guys in a little bit.